rectifier using SCR. File, new schematic, part, voltage. You type voltage here, so will give you different voltage sources. This is power source. I'm using that voltage source as a power source. So then we require SCR. Type SCR here, rotate, Control R. Then we require load resistance, so R. One more voltage source is required because we need to apply the pulses to the gates of the SCR. That's the reason I require one more voltage source. I'm using this as a pulse generation circuitry. Then connect all these using wires. Now connect ground here. Pulse should be applied in between gate and cathode. So pulse generation circuit positive terminal I am connecting to gate of the SCR. Then negative of the pulse generation circuit I am connecting to the cathode of the SCR. SCR is a 3-terminal device: anode, cathode and gate. Okay. Now I am using this voltage source as a power source. So you go to advanced, sine, because it is sinusoidal voltage source, so offset is 0, amplitude I will choose 325, frequency means maximum amplitude 50 Hertz, delay, that is rest keep as it is. Then this is here I am choosing voltage source as a 50 Hertz and whose peak value goes to 325 in positive peak, as well as in negative peak it goes to minus 325. Such a voltage source I have chosen. Then this voltage source I am using as a pulse which is required for SCR triggering. So go to advanced, then you choose this pulse. Here I should specify this pulse start from 0 and it goes to a voltage of 5 volts after a delay. This is firing angle. If you are choosing a firing angle of 90 degree, then choose 180 degree means 10 millisecond, 90 degree means 5 millisecond. Rise time means how much time it takes to that pulse to change from 0 to 5 volts. This ideally I have chosen as 1 nanoseconds. Fall time I am chosen as 1 nanoseconds. T on. The duration of the pulse means that pulse remains in 5 volt status for how long? I will choose 1 millivolts because yes, period is this pulse. After one more pulse, after how much time it should come. So in this cases my power source frequency is 50 Hertz. I require pulse after each 20 milliseconds. That's the reason period of pulse I have chosen as 20 milliseconds. Then so resistance value, this is instead of the load I am using a resistance. you choose some 5 ohm resistance load. That's the reason the resistance of this I have chosen as 5. Okay, then this is SCR. So now if you simulate, we'll check what happens, we'll see. So I should simulate for how long? Means assume that I want to check the 3 cycles of the power output. So 20 millisecond means 1 cycle, 60 millisecond means 3 cycle. Starts time to start 0 from 0. Okay, maximum step size 0.1 milliseconds you choose. That's enough. Okay. So if I have simulated earlier, so it is giving you an error like this. See, if I simulate right now, it is it's giving you unknown subscript called XU and something SCR. What is the meaning? Means this SCR's only symbol we have included here. This model is not included. So right click on that. Right click on the okay. Now I should include its model. Its SPICE model is there in website, so I will Google here. So I will write SCR SPICE model. It will show you different companies. So I will choose st.com. So ST micro system SCR I am going to use. So I will search SCR SPICE model. Okay, it is showing you different SCRs. This high temperature SCR I will choose it. Zip file is opened. So this is the model. I will copy this to C drive to proper path. C drive, program files, LTC, LTSpice, lib, copy, paste, continue. Okay. So I require path of this, this is a lib file, library file. So you take a path of this, go to properties. So you add that path here. So click right click here. Write .inc include. Click that path. Copy the path. So it is in this path again. So again that so name of this file I require so write .lib because that library file I have included here. Okay, once this is over, we will open that library file. Go to Word. Go to respective path, program files, LTC, LTSpice, library, high temperature SCR, ST high temperature SCR. It's giving you model. Here it's having a sub-circuit like I am choosing this TN5015H68. Okay, so control C, then right click on this. Here it will show you SCR. So instead of that, copy that name. Okay, one more thing is I want to check the net list is in a proper order or not. For that, Here you can see A kg, A is 1, K is 2, gate is 3. Remember, anode 1, cathode 2, gate 3. Here right click, open symbol, you check the net, right click here, A is given netlist order is 1, okay, correct, no problem. So cathode, here it is 2, if it is 3 you make it 2. Right now it is in proper order. If it is not in proper order, we need to edit it. In here gate is 3, there also it is 3, okay, no problem. So now if I run, yeah, it has maybe giving you an output. So I should I will keep this as a probe here. I am measuring the output voltage with respect to ground. See here, I have chosen a 90-degree firing angle, so SCR is turned on at 90 degree, and again at 10 millisecond it has turned off. Again for next same thing, half wave rectifier, half control, half wave it is, so only in positive half cycle from 90 to 180 it is conducting. So I can if you want to check the currents in the load side, so this is a current, it is giving you in load, so you can see here load current it is, okay, load current, because the resistance is we have chosen a load as a resistance is in phase with the voltage, okay. If you want to check the input voltage, everything, so choose set the probe reference here, and I will check the input voltage. So I think I got input, then we will see the pulse here, view, set probe reference, pulse. So you can see here, this is a pulse, red color is a pulse, and load voltage, okay. So all the things are there here. Add different float, add float planes. So I will choose this, copy here, we'll see, add trace, okay. You want to delete this here, delete, and this is Control C. So add trace here, okay. So delete this. See, I have shown you here right now, it is showing you load currents as well as, okay, one more plane we can add here, okay. So I will if you want require this is load currents. If you want load voltage, I can show you load voltage also. So load voltage, is this is load voltage. See, now it is showing you input voltage, pulse, and load voltage. So in input voltage it is taking from 0 to 325 and it's coming back to minus 325. So in the first half cycle at 90 degree, because it is 5 millisecond we have chosen, because firing angle becomes 90 degree, we have chosen that SCR will turn on there. That's the reason load will receive that voltage starting from 90 and it goes till 180. So this is my circuit. See, this is power. So once SCR is turned on, it is acting like a closed switch. It is just like a conductor. So at 90 degree it will turn down. At firing angle of 90 degree it will turn down till 180 degree it conducts. So during that time the load is connected to source. So load will receive entire voltage from the source from 5 milliseconds to 10 milliseconds. That's all.